Hello everyone! I went flying again! Last weekend, the weather finally got good enough to go out flying again. After a long and dark winter where the closest thing I got to doing this was flying planes indoors, which, while fun, is not really the same as doing this outside in the sun. This, however, did not stop me from building yet another 3D printed plane of mine, and since the weather was so good, I even took it outside to see how it would do. But before we crash 300 grams of LW-PLA into the ground, let me tell you about how this entire thing came to be. As mentioned before, I was getting the itch to fly something again while it was winter. It was too cold, it was too dark to fly outside, so the best thing I could do was take part in an indoor flying session. The RC club that I'm part of does rent a decently sized gym from a local high school that we can use for indoor flying for 2 hours once per week. Now, none of my designs can really fly in even a larger gym like this, so I had to get new flying equipment. An opportunity just kind of presented itself when a pilot from the club was retiring and basically giving away their old indoor planes. So I picked one up for 20 euros, plus some batteries for another 20, and there we go, I had my indoor flying plane, and the entire story is now over. That's it, that's the video, you can go. It of course didn't stay there. Admittedly, the plane I bought is fine. There is nothing wrong with it. It flies just fine. Yeah, it has some signs of use, but for 20 bucks I'm not complaining. It's great. Like, honestly, I could have been perfectly content with just flying that thing, but there's this thing called I live in a different city and I don't own a car, so I have to take public transport. And doing all that with a 1 meter long plane in tow is not very easy to do, especially if you don't want to look weird. I really underestimated how hard this thing is to transport. I mean, it's an indoor plane. It's really, really light. So that means if you transport it outside and there's just a very slight gust of wind, this thing wants to take off from your hand. And because it is actually so large, like it's almost a meter wingspan and 1 meter in length, it wants to take off. It wants to rip its wings off from a little wind gust. This is really annoying. So essentially, transporting this thing to the indoor flying location was really annoying, and I wanted to solve that. How would I solve this? Well, I don't really have anything to put the plane inside. I tried like a big trash bag, but the plane is so large it just doesn't fit even in the largest one I could get. And even still, it would just be like a massive bag that I have to shove with me in a train, and I need to make sure that no one bumps it because the plane is very fragile and easy to break. So it dawned on me that this was going to be another one of my 3D printing projects. Originally, the idea was to copy the design of the plane, buy some Depron foam plates, and rebuild the plane exactly as is, except I would 3D print the wings. This would enable me to first use a proper airfoil and not just use flat plates, which would increase lift a little bit, which is a nice add-on, but also it would enable me to print the wings in different parts so that they are removable. Put a little carbon rod inside and then just take the wings off when you transport it. This would make it fit into a much smaller bag and make it much easier to transport because, well, it's still 1 meter long, but now it's only about 30 centimeters wide instead of 85. So that was the original plan, but when I thought about it, really, I kind of want to try 3D printing the entire thing. So here's my reason for that. Depron plates are great. They are so lightweight that even the best 3D printing settings are not gonna come close to them. But there's this thing where they like to bend very, very easily, and pretty much any Depron plate-based plane that you look at has these tiny little carbon rods everywhere for extra rigidity, and that sounds like a nightmare to assemble and keep from breaking. There are newer designs that just use way thicker Depron plates, but those are not the ones that I had, and I have a feeling that, like, it's not the most efficient thing aerodynamics wise. Like, a lot of those planes seem to be using 3-cell LiPo packs and mine were only 2-cell. So really I wanted to do something that's not using those super thick Depron plates either. So the idea came, well, the Depron plates really only need all this reinforcement because it's two separate flat plates that you just kind of stick together in like a plus sort of thing. I could just 3D print the entire fuselage in one part. That would make it much more rigid and not require those carbon rods for stabilizing it. And that's how the entire thing started. Before we continue, I'd like to thank my sponsor, PCBWay. If you are working on a project of your own that requires parts that would be hard to make yourself, or just generally parts at a much higher quality standard, you can go to PCBWay's website and order anything from PCB prototypes, assemblies, CNC parts, 3D printed parts, as well as stencils or even flexible circuit boards. The ordering process is simple. You just upload your files, tell them some stuff that you need, and you'll quickly receive a quote, which once accepted, will mean that your part can get shipped out within as fast as 24 hours. And if you have any questions or require further help, they even have a live chat service that stands ready for you. So if you need some custom-made project parts, don't delay, go to PCBWay today. I hopped into Fusion 360 and immediately threw away the entire plan I made. Yeah, this is a thing that I tend to do sometimes. I had another idea that I wanted to try first, and that was a bit more ambitious. So, I had the idea, because we're 3D printing it, I could try a technique that I've attempted before but never really tried super hard, which is vase mold printing. This is a technique that's mostly used to minimize stringing when printing lightweight PLA, but it also has the interesting effect of producing very lightweight parts because it doesn't print with infill. You just print one outline and that's your entire part. So a lot of lightweight 3D printed RC planes actually use vase mold printing for better quality and weight reduction. The one problem being that, well, if you don't have infill, all you have is just an outer shell, and you need to reinforce the parts somehow. Typically this is done by introducing tiny little cutouts into the part that make the slicer print a double-sided wall, which effectively acts as a reinforcement strut. And my idea was, using this technique, I could potentially print something that was lightweight enough, but still have a full 3D fuselage. This is something completely unheard of indoor planes of that size, so I wanted to really get it to work. So I went ahead and designed this thing that doesn't really look that great, but honestly looks were not a priority for this project. I just wanted it to work. I spent quite a lot of time adding these tiny reinforcement struts to make sure that the fuselage would actually be rigid and just not collapse into itself. And I came up with a design for my removable 3D printed wings, which were using a proper aerofoil. My hope is that even if I can't get it as light as a Depron plate plane, the actual airfoil shape of the wings would generate so much additional lift that essentially it cancels out and the plane flies regardless. Which, to be fair, is a decent idea if I hadn't fallen for the same trap that I fell for before. So, yes, I made the wings removable, but I still wanted to kinda make the plane a little bit smaller so, you know, it's easier to transport as a whole. And this is the problem. I keep doing this. I keep making the planes smaller. Do not make the plane smaller. The smaller you make your plane, the worse it will fly. And at some point, it's so small that it's not going to fly at all. I learned this with the small-scale models of the F-111, which kept getting bigger and bigger and bigger because they just kept flying better when I increased the size. Because there's this funny thing where the lift you get increases more than linear with your wing area. So you double your wing area and you get something like 4 times the lift. So I spent all this time on this design, which I ended up getting printing pretty well, assembling pretty well. Like, it worked. I got a prototype to work with all the electronics in, and then I took it to the gym, and I tried to take off, and guess what happened? It was too heavy. Or rather, it was too small for the weight. Yeah, the best I got was like a tiny little hop, followed by a big crash back into the ground, and at that point, I was just... time for me to accept the Fell For It Again award. I'll own it. Like, making the plane smaller is not something that tends to work. I need to stop doing that. So I went back to the drawing board. My first idea was to do the same thing as the F-111 project, which, has worked pretty well so far. Just make the thing bigger. Really, I wasn't a huge fan of the whole design that I made. Like, it worked, and it had the full 3D fuselage, which is really cool, but at the end of the day, I wanted a plane that flies and is fun to fly, not something that wins an engineering award. And the entire 3D fuselage thing has one fatal flaw. Or rather, the flat plate design has one crucial advantage. So if you look at one of these flat plate designs, what do you notice? If you look at it from straight on the top, there's wings, and then there's fuselage, and both of those are made out of the same flat plate, which means, aerodynamically speaking, the fuselage is also wing. That hugely increases your wing area, and again, hugely increases lift. The one problem with the 3D fuselage is, well, it's not a wing, it's a fuselage. It's not flat. It probably has a little bit less drag, but it doesn't generate nearly as much lift as just a flat fuselage does. And this is the thing, together with the too small size, that I think killed the first prototype. So, I could have made it bigger, but because I have to acknowledge that more wing area is more better, especially for an indoor plane which has to fly slow, I decided to go with the flat plate design I envisioned from the beginning. So, essentially, I completely started from scratch, just completely from the beginning. There were a few iterations I was going through. At some point I was considering to maybe even make a double-decker design, because I have seen some of those and, well, they have twice the wing, and that should help them get even more lift. They have a lot more drag, but, we want to fly slow anyway, so... But at the end of the day, I wanted to not overcomplicate it, so I went with the same sort of, resembling an XTR-33, like it's a mid-wing aerobatics plane sort of design, and I made sure that it is the same size and scale as the plane that I bought, and I made sure it takes full advantage of the flat plate fuselage as a wing sort of design. And that became the XTR-33 version 2.0. Yeah, I didn't give it a name until now. XTR-33 because, XTR-330. I'm very creative, I know. And the design for this was honestly very easy. I mean, it's two flat plates. You just make two sketches, you put those together, you put a little bit of a rounded edge in the middle, which increases the root strength between the two surfaces, and then you add a wing. The wing profile I chose is a NACA 0018, if I remember correctly, so it's a symmetric profile since it's an aerobatics plane, so this is gonna be able to fly upside down as well. And, well, it's a pretty thick profile. It's gonna generate quite a lot of lift, I hope. Which, again, I just had to accept that this was not gonna be quite as light as a Depron plate. Lightweight PLA is still PLA. It's still plastic. It's still denser and heavier than foam, even if you have the lightweight stuff. So I just had to accept that it was gonna be a little bit heavier, and having the 3D profile airfoil was, again, gonna generate extra lift and hopefully help the plane fly regardless. And this worked. I just wanna say that this worked. This is perfectly fine. This was a good decision that I did not regret. While I was finishing the design in Fusion 360, I was importing beta versions of it into Prusa Slicer to sort of get an estimate of how heavy the entire thing would be. And what I was seeing was not entirely satisfactory. It was going to be about 150 grams heavier than the plane I bought. Which doesn't sound much, but if you consider the thing was only 250 grams, that's quite a bit of weight increase. So, I decided to do a bit of investigation and change my usual lightweight PLA print settings to make them even lighter. since the plane is not gonna be flying outside and just inside, we don't really have to make them as rigid as outside parts because, well, there's no wind it has to contend with, it's gonna fly really slow, and there's gonna be a smooth gym floor, it doesn't have to land on grass. So really it doesn't need to be as rigid. So I changed my print settings by making the wall width 0.4 millimeters instead of 0.5 and reducing the infill to 3% from 5% gyrite infill. This made the parts a good bit lighter, but also a good bit more delicate. At this point, the 3D printed stuff was about as bendy as the Dapron plates. Really, the only advantage they had was that it was one single piece instead of two kind of glued together, so it was still a little bit more rigid in like a torsion way, but it was pretty clear that this thing was gonna like break very easily if I don't fly it properly. Almost a little bit of foreshadowing here, but I'll talk about that later. So, after the design and the neoprint settings were done, I started printing all the parts for it, ripping out the electronics from the old prototype, which just sits in a corner being sad now, and I assembled the new thing. And it went great, there were no problems, it all went together just fine, everything went just like I expected. And then I went to check the center of gravity and, So, remember when I said that 3D printed parts are just not quite as light as the Dapron construction? Well, I just copied the design of the Dapron plane I brought. That was not a good idea, because the 3D printed parts are heavier and, well, it shifted the center of gravity quite a few centimeters back. So far back that even with the electronics as far forward as they will physically go, the center of gravity was way too far back to make this thing ever have a chance at flying properly. So that was a bit of a bummer. That was a lot of time spent printing and quite a bit of filament and a lot of time assembling it. But this thing was not gonna fly. I would have to add like 100 grams of weight to the nose, and again, we want this thing to be light. There's no point. So, yeah, I jumped into Fusion 360 again and put the wings all the way back. I think I even elongated the nose a little bit to like shift the center of gravity further forward. And then I printed a new version. And this one still was pretty borderline, like the center of gravity still needed the electronics and the battery to be as far forward as they can physically go, like the LiPo was very close to getting shaved by the propeller. But the center of gravity was okay. It didn't look okay, because if you just look at where it is on the wings, it's pretty far back, but again, the fuselage is also wing on this, and the fuselage stretches pretty far back, so it actually flew fine like this. Like, the center of gravity on this can go pretty far back in reference to the wings. So, finally, after quite a few weeks, because I was busy with university in between, I took my new design to another indoor flying session and tested it out. For the first time, like, I mean, the SN5 of the F-111 kind of flew, but I don't really count it because it would have crashed if you turned. For the first time ever, a design that I made from scratch took off and flew. I'm gonna allow myself a little bit of self-applause here. This is like the 4th plane I've designed, and it's the first one that worked. But yeah, it flew. It ended up being about 100 grams heavier, so like in the 340 gram range compared to the 250 grams of the Dapron plane, so still a good bit heavier, but the 3D printed airfoil helped a lot because it could fly really slowly, which I found out because I immediately stole it and flipped it on its back. So the triumph from this was pretty short-lived. There was a little bit of a problem that I didn't think about the entire time I made this project. I only flew that Dapron plane I bought once, and then I immediately went and designed my own. Because I thought, and know, it's gonna be easy. It's a very simple design. It's meant for indoor flying. It's gonna be great. I never really considered that indoor planes are way more sensitive than outdoor planes. Like, way more sensitive. Look at the size of those control surfaces. I never thought about this, because I use the same philosophy I use for my outdoor plane, which is just maximum deflection possible, which was like 135% on the ailerons. Guess what it did? It flipped on its back. It was so sensitive, I immediately lost control, and it flew into a wall, and it broke in half, because, yeah, remember when I said the parts are really delicate with the new extra lightweight print settings? Yeah. I had CA glue with me and some accelerant, so like I was prepared for this. So I glued it back together a couple more times. But yeah, that snap was pretty bad. Like it damaged the plane quite a bit, so much so that I wasn't really comfortable with risking to crash it again, because I think that would just completely break it. I was thinking of just sending it, and then like if it breaks, I don't care, I can just print a new one, but I kind of wanted to test it flying outside as well, so I didn't want to quite break it just yet. But yeah, the design of the plane was just fine. The reason why it crashed is the idiot pilot. The idiot pilot being me. I didn't spend enough time preparing. I literally had a plane that exactly that size and design that I could have practiced with, and I chose not to. So this is just 100% on me. This is my fault. I goofed up. This is why the plane broke. Yeah, I'm really becoming that stereotype of just like, I spent all my time in the design stage, I never spent any time on, you know, learning to actually use it. So, yeah, I guess I started to idiot-proof my own designs against me. Anyway, the plane sat around in a corner for quite some time after that, because, again, I needed more practice flying it. But again, I didn't want to transport the huge thing to the indoor gym. So I thought I was just gonna wait until the weather was good enough again, and I'd take it outside and fly it there. Because I wanted to test it outside anyway, because I just wanted to see how it behaves. So now, where the weather is finally good again, I went out with my dad to the flying field with the XTR-33 in tow, and we flew a bunch of things. So here's some recordings from that day, from the Insta360 and my OnePlus 7T Pro, which I finally found out you can actually film videos with the 3x optical zoom lens. Only took me 6 years of owning it, but yeah, here, enjoy some flying footage.
Lass ihn marschieren, lass ihn marschieren, lass ihn marschieren. Die marschiert nicht. Gut, doch, war auch gut. Ja, alles gut.
Los!
Wenn sie landen will, musst du sie auch lassen.
Nee, die ist ja nicht.
Oh.
Da war ich mit dem Leerlauf ein bisschen zu geil. bei 200 Kilometer pro Stunde.
Nicht schlecht.
Sieht bei der Großen nicht so schnell aus.
Ja.
Hinterher. Das sind nur 200, stell nicht so an. Kann nicht mal Vollgas.
Wie viel PS hat der Motor?
9 oder 10, glaube ich.
So they just had a mid-air collision. My dad and someone else collided in mid-air. My dad just got the tip of his propeller ripped off, but the other plane is somewhere. They said it might be in the water, so we might have to go get a boat to go find it. So here's to that adventure. It's gonna be interesting. I don't see anything in the water though, so maybe it's just stuck somewhere in the weeds, which is probably worse, because they're not gonna find it. Ah well.
Motor an.
I was pretty aware that it would probably only fly once, if at all, because those super small wings, they're meant for gym floors, they're not meant for grass. They're probably going to dig in, and then the very delicate fuselage is just gonna snap in half again, and then that's the end of the plane. I was pretty sure that that was gonna happen, but again, at this point I didn't care. If I really wanted this thing to work outside, it wouldn't be really hard to design some larger wings and print the parts with my usual print settings, which are more rigid, because outside I can just fly faster. That's not a problem, so we can offset the extra weight. And yeah, so I strapped on my Insta360 and I sent it. And to my surprise, it was able to take off from grass. I did not expect this. I thought these super small wheels would just not work, but it took off and it flew really well. Like it wanted to pull up quite a bit, but I trimmed that out and it just flew fine on the 2-cell LiPo, like the ancient 2-cell LiPos with like 50 milliohms of cell resistance. For context, normal cell resistance are like 4 milliohms. So yeah, it worked just fine. Like this thing flies perfectly outside. It was pretty low wind conditions. Like once wind shows up, I'm pretty sure this thing is not going to be as fun, but like on a good day, this thing is great. So great that I decided to go ahead and build that outdoor version. But first I had to land, and remember when I said the plane would probably snap in half on landing? So that happened. It broke exactly at the same point where it snapped before for me flying into that wall. And at that point I wrote the plane off. Like, it's still broken in half, the front is missing, it's just sitting on my shelf waiting for me to rip the electronics out after I do some B-roll for this video. And then the electronics are going to go into the new outdoor variant, which originally was just going to be the same thing, printed with more rigid print settings and larger wheels, but I thought, there's some stuff I can improve. For one part, the wings could just be a lot bigger. I just kept them the same size as the indoor plane, and yeah, I mean, it works, it flew, but more wing is more better, right? So I made the wings about 14 centimeters longer, so the wingspan went from 81 to 95 centimeters. Of course, I gave it the bigger wings, and I also replaced the aft wheel with a skid sort of thing, because like that super tiny wheel is just like, I don't really expect this to work that well, especially outside, so this skid is just fine. And that's the plane that's currently being printed. So I'm gonna put this together, I'm gonna put the electronics in this, and well, I'm going back out tomorrow. I don't think I'll be able to finish it for this weekend because I just started printing the parts, and it's a lot of parts. Like, some of those take 10 hours to print. So I'm not quite sure if I'm gonna get it done, but there's always next weekend, because I have other prototypes to fly too. The SN6 of the F-111 has been sitting around completed since like September of last year, when it just started to become too dark and too cold to fly. I made a mini A10 to fly with the old parts from the SN5 F-111. Never made a video about that, but yeah, I'm gonna try flying that, and depending on how it goes, I might make a video. I also built a JRM Junior, which is, I bought the design for that, and also built it just because that's more of an aerobatic EDF plane, like the other ones are more like high wing loading scale kind of planes. So I wanted to try something like that. All of those have not been flown yet, so I have lots of stuff to test fly, because those are all ready to go flying, so I just need to take them outside and, well, fly them. So yeah, there's plenty of stuff that I can do. And as far as the XTR-33 goes, I put the plans online on printables. There's the original plans for the indoor version that you saw flying in the video, and there's also the current status of design for the new outdoor version. I'm probably gonna change some smaller things about the design, like there will be a final version once I actually build my prototype and fly it. But I put it online anyway because, like, really there's nothing that's different about the design that should make it fly worse. Like, yeah, it's gonna be a bit heavier, you're gonna have to fly a bit faster, but it's for outdoors, like, there's no walls you can fly into. Well, unless you try to. But yeah, if you want to build your own XTR-33, you can find it on my printables for free. You can actually also find the plans for the small A10 I've built. Again, not test flown yet, I have no idea if it works. It's a bit more of a complex design, but I put those plans online as well. So if you want to build your own, you can. And as for the F-111, well, I'm going to test fly that. I have a feeling it's gonna work this time. I know I say this every time, but I have a feeling it's gonna work this time. It is 40mm EDFs instead of 30s now, which means it has way more thrust. We're going up from 300 grams of thrust to almost a kilogram of thrust. It's only 100 grams heavier than SN5, and it's a good bit bigger than SN5 again, so we're gonna have more lift again, and like, I think it's gonna work this time, guys. Really, I hope so. And when that flies, I can build a swing wing version, and when that works, I can build the full scale version with these 60mm EDFs. That's gonna be cool. So yeah, plenty of projects to do. I'm not entirely sure how the timeline is gonna be. I also have a pretty busy university semester, but I have a lot of classes where, like, I don't need to physically be present for them because I'm doing a lot of project classes, so I might have some more free time to do stuff like this. I'm gonna have to see. There's of course also the upcoming bench meet and some overclocking videos again. The RX 580 finally ran some benchmark. There's gonna be a video about that. So I guess with that, that's gonna be it for this video. And until next time, goodbye.